just saw your recognize your handwriting. I'm like, dude.
I can tell that's you.
I know.
Look.
I know you can.
My husband's never had a class with you, but he's seen your writing on the walls.
Yes, he has. Yes.
I'm surprised.
Napoleon's 208, Randy 114, Modoc 222. Leave my mark. It's like a cat.
Oh no!
All right. Now, we've got a good intuition. We've got a good intuition. We've got a good intuition about how big standard deviations be big in quotes. If data is more dispersed, it should have a larger measure of variation. If it's more tight, can I call it tight data? If it's more tight, it should have a smaller measure of dispersion. Can we agree with that? Is that a fair place to start? I think it's decent. Now, I want to take Eric's idea, which I still love, even though nobody uses it, but apply it to what people do use. So take your idea of measuring distances, but instead of measuring distances from data point to data point, which is somewhat arbitrary, let's measure the distances from the data points to a fixed central point, which I think is what you guys were getting at over here with the 81s, 81s, 80s. Let's not lose that 81, right? Or that 82. So, how would we do that for Ernie? Let's look. Here's both of their averages at 81, right? How much distance is there between Ernie's low test score and the average?
2.
2 points, right? The low test score is a 79, yes? His average was an 81, that's a distance of 2. Beautiful. How about from his second lowest test score to the average?
1.
1. How about the one that was at average? 0. And then we've got this guy here, which looks like a 1. And then this guy here, which looks like a 2. So notice this is similar to what you came up with, Eric, and actually this is the one I had calculated when you were describing your method too, because I misunderstood what you told me. This is where I got my 1.2 from. If you average those 5 values, 2 plus 0 plus 1 plus 2 plus 1, you get 6 divided by 5, which is 1.2. Is that fair? I'm not saying it's right or wrong. Is it fair? Because now we've done Eric's idea of distance with Kendra and Linda's idea of not forgetting about the center. And I kind of like that because it keeps those two ideas fused together. Can we do the same thing for Bert? We could. I'd like to pause though and stop. And the reason is nobody does this. I wish I knew why. Well, I have a mathematical reason I know why. I actually had somebody on YouTube post a comment to one of my videos that it's not one of my students. I love this. I'm like, I never get comments from my students. I get comments from people in French. I'm like, can you please just put that in English for me? Because I know you speak better English than I speak English myself. And they asked me, why don't they use that? That right there, what we just described, is called the average deviation. Don't memorize that. It's not crucially important. I mean, it's a wonderful little. Excel has a command called avdev, A-V-E-D-E-V. The problem with it is it's based on the absolute value function. Remember what the absolute value function looks like in Math 111? You guys took Math 111? Remember if you graph the absolute value function, what it looks like? It looks like a V with a hard point. Those hard points are tricky in calculus. You've probably learned that right now, aren't you, Eric, in the limiting idea? Those hard points are tricky to deal with. And there's a lot of calculus in the back of these mathematical calculations, even though we're not going to do the calculus. I saw some people turn gray right now. We're not doing calculus in here. I'm just going to let you know that there is calculus at work. We're just kind of like when we turn our cell phone on and it just comes on. We just trust that the binary arithmetic is working. Yes, trust it, it works until it doesn't. So, unfortunately, nobody does that way. They do something similar, but you'll see how it's more calculus-centric, how it's more agreeable calculus-wise when we get into the mathematics. So let's turn this off for a moment, and let's go back to Ernie. What I'm going to do is we're going to develop the measure that Chrissy already told us about. And it's, how many of you had heard